Let's do the verification and validation. Verification is looking at whether we solved the mathematical model correctly. So it's looking at whether these steps were done right, whether we input the right mathematical model and we solved it correctly. So we will do that. And validation is looking at, is complementary to that. It's looking at whether the model we have, the mathematical model we have picked, is a right representation of the physics. And for that, we need experimental data, which we don't really have over here, so we won't be doing validation. And under verification, the first thing is to do sanity checks, and we have been doing that as we've gone along, looking at temperature distribution, looking at heat flux vectors, and so on. So sanity checks we have already done. The mathematical model consists of governing equations and boundary conditions, and the boundary conditions we have checked as we have gone along. So we are pretty confident that we have, our boundary conditions and our results are consistent with the boundary condition in our mathematical model, so we have input the right boundary conditions into the tool. And then the governing equations contain, the physical principle contained in the governing equation is energy conservation or energy balance. So we can look at the results and check if the results are consistent with that physical principle, which is energy conservation. Okay, so we will check that by checking the reactions, as I talked about in the big ideas in FEA. Okay, so with those checks, we can be fairly confident that we have input the right mathematical model into the tool. And in terms of the numerical error, how the tool has solved it, as we discussed in this problem, really the only thing we need to worry about is doing a mesh refinement, because it's already using the second order interpolation with the mid-side nodes. And in practice, you never go to the third order interpolation. So to check the numerical error, we'll do a mesh refinement. Okay, so that's to be done. And the third aspect of verification is to check versus hand calculations, and part of our sanity checks involved checking boundary conditions via expectations of trends. So we've done that, and then here we have an exact solution to the mathematical model, and we need to check that. I'm not going to do that here, but if you come to Cornell and take a heat transfer course with Professor Luge, he might make you do that as part of the homework, because he often assigns this as the homework in his heat transfer course. So for verification, then we will do, we'll check energy conservation, and we'll do a mesh refinement study.